Equations number 8. Analyzing a system of equations. Learning target 1, I can explain the solutions of a system of linear equations graphically. So I'm just going to remind you that a system of equations is two or more equations that share the same variables. And when we solve a system of equations, that's what we're looking at today graphically, we're finding the value or values that satisfy, that makes both equations true or equal to each other in every equation in that system. So not just one of the equations, but what I'm saying is all the equations. So if there's 4 equations in the system of equations, then it has to satisfy all 4 of them. So there are 3 different types, just like in the last lesson we did. There's one solution, infinite solution, and no solution. So I'll go through each one of those. And so we'll start here with one solution. So remember, one solution would be the point, or when you solved it, it was the point that satisfies both equations. And I can see that by looking at the graph, and you will notice that it intersects, those 2 straight lines intersect at one point. And if it intersects at one point, that means there's one solution. And that one point where they intersect, which we call the intersection point, is what satisfies both equations. So the question here is, describe what the graph looks like. Well, it's 2 straight lines that intersect at that one point, which technically is 1, 6. And then we're going to justify, which means prove, and we're going to prove it by actually solving it here. So we're going to take that first equation, which happens to be the red line above, and we're going to justify that the point 1, 6 is actually a solution. So we're going to put 6 in for y, because remember the point is xy. So our y value is 6, so I'm going to put 6 here, equals -1. So we're going to input the x, which is 1, and we're going to add 7. So we're just going to solve this. 6 equals multiplication here, so -1 times 1 is -1 plus 7. And one more step, -1 plus 7 is 6. So I can guarantee the point 1, 2 satisfies this equation of the red line. The blue line, the equation is y equals 3x plus 3. Again, I'm going to put this solution of 1, 6 because the definition of a solution of equations is it has to satisfy all the equations. So I'm going to put in 6 in here for y, take 3 times 1, I'm going to input 1 plus 3. So 3 times 1 is 3, add 3, which is 6. So 6 equals 6, which is also true. So I can justify or prove that the equation, or I should say the point of 1, 6 satisfies both the equations, which means it's a solution. So that is one solution. Now we're going to look at infinite solution. So infinite solution is any point on the lines that satisfy both equation. And infinite, again, means there's infinite amount of solutions. There are many solutions. So if you look at this, and you're going to notice you only see one line. That's because if you graph 2 lines that end up on top of each other and form one line here, that means that they are the exact same line. So the equation of y equals 2x minus 3 and the equation 2x minus y equals 3 are graphed exactly the same. They have the exact same points if you would graph them. So that means I could look at their tables and I could see that there are many points on this line. Whoops, I moved it. That would satisfy both because they're technically on top of each other. So that means they intersect infinite times. So what does this graph look like? It's 2 straight lines that are graphed as the same line. So 2 lines that are graphed as the same line. And how do I justify the graph proves that there's infinite solutions? The 2 lines intersect infinite number of times, which indicates there's infinite amount of solutions that would satisfy both equations. So since they're the same line, that means they intersect this infinite amount of times, which indicates there's infinite amount of solutions. So in other words, I could pick any point. So let's pick a point here. Let's go with 3, 3. So I can take the first equation here. So I'm going to plug 3 in for y and 3 in for x. I'm going to take 2 times 3, which is 6, and I'm going to subtract 3, which is 3. So the point 33 does satisfy the first equation. We'll check the second equation. So I can take 2 times 3 minus 3 should equal 3. Well, 2 times 3 is 6 minus 3 equals 3. That is a true statement. So the point right there, it has to be on the line, on both those lines, satisfy it. So I could sit here and do the same thing with 4, 5. So if I would replace the 4 here and make this a 5, well, 2 times 4 is 8. Minus 3 is that 5. So 5 equals 5. It would make that equation true. And then I check the other one to justify. I'm going to make that x5. And that x should be 4. Because I'm looking at this point right there. And I'm going to make this y5. Ooh, let's just erase that and start over again. Okay. So we have 2x minus y equals 3. And I'm checking the point. I should write that up there. 4, 5. All right. So now I'm going to put in 4 in for x minus 5 equals 3. So 2 times 4 is 8. When you subtract 5, that does equal 3. So I can guarantee that the point 45 satisfies both equations. So I could sit here forever and ever and ever and do this, but I know that if they're sitting on top of each other, intersecting, that means there are infinite amount of points that make that solution true. Okay, let's look at no solutions. So no solutions would mean that there's no points that satisfy both equations. So when you look at this, you will notice that you see two parallel lines. So I have two equations here, y equals 3x plus 4, which is the blue line, and y equals 3x plus 0. So the first question is, describe what the graph looks like. Well, I notice there's two straight lines that are graphed, and I also can tell they're parallel lines. They are never going to intersect with each other. So how do I justify that there's no solution? Well, since the two lines do not intersect, that means there's no solution, or there's nothing that intersects and no points that both lines equal and intersect that would satisfy both equations.